Hey guys, so in this video we're going to be talking about isotopes and ions, and the way we're going to do that is first we're going to use this picture to calculate how many protons, neutrons, and electrons are in these particular atoms. And so one thing to keep in mind, if it's red, then it's a proton. If it is white, then it's a neutron. And if it is black, then it is an electron in these pictures. That's the key. And so here for our protons, we have 1, 2, 3, 4, 5, 6, 7 protons. We have 1, 2, 3, 4, 5, 6, 7 neutrons, and we have 10 electrons. And in the middle atom, we have 7 protons, and 7 neutrons, and 7 electrons. And in this far right atom, we have 7 protons, we have 8 neutrons, and we have 7 electrons. And we're going to use this to kind of model a few things that we need to understand. Because all 3 of them have 7 protons means it's nitrogen. That is why it's nitrogen. It doesn't matter about the neutrons, it doesn't matter about the electrons. 7 protons always means nitrogen every single time. Now, the next thing I want us to look at is how we see that these two on the right, well, the center and the right, are neutral. And the reason why they're neutral is because they have 7 protons and 7 electrons. So when you have the same, so neutral, all that means is that you have equal protons and electrons. That's what that tells us there. Now on the left atom, it has the word anion, and so we want to figure out what that means. So if we compare the anion to this one, the difference is that the anion has 10 electrons. And so our difference, or our definition, is an anion has more electrons. And we can also see in the symbol that it has a -3 charge, while these other two are neutral. And so that means an anion has more electrons, which makes it a negative charge overall. It has more more electrons than it does protons. And so the key words here that we want to make sure that we know are anion and neutral. Those are kind of our vocabulary words for this. And we can kind of determine based on the picture what some of these numbers and the symbols mean. So we can see that all of them have a 7 in the lower left-hand corner, and all of them have 7 protons. So when you look at this nitrogen here, this 7 is the atomic number, or the number of protons. It means the same thing. Whereas this top number, we have 14, 14, and 15. So what the first two have in common that the third does not is its row of neutrons, which that's kind of a bad color for actually seeing. So let's go with this pale blue, this purplish blue. Okay, so it's protons and it's neutrons. So this, if it has a 14, that's its protons plus neutrons, but 7 plus 8 is 15. And so this number up here is the atomic mass. Okay, and so this kind of is pretty helpful for helping us figure out some vocabulary. And now we're going to take a look at another set. So with this set, we're looking instead at lithium. And so if we count the protons, we have 3 protons, or 3 red circles, in all of them. And that is why they are all lithium, because lithium is number 3 on the periodic table. In the first one, we have 4 neutrons. We have 4 neutrons. And here we have 1, 2, 3, 4, 5, 6 neutrons. And so because they all have a different number, that also accounts for why this one at the end has a higher atomic mass of 9, because 3 plus 6 is 9. And so we can see that lithium, they all have to have 3 protons, but they do not all have to have the same mass because their neutrons could be different. And then we can see that this one on the left has 2 electrons, 3 electrons, and 3 electrons. And so again, these two on the center and right are neutral because they have the same number of protons. So when my protons are equal to my electrons, that means we have a neutral atom. But we can see with this cation, we can see that I have less electrons than the other two, and that I have a positive 1 charge. So that means a cation has less electrons than a neutral atom, which makes it positive. And so we have a great phrase for this. So we know that cats, like kitty cats, so cats, I'm gonna draw one here. Woo. Look at my cat. Beautiful. Cats have paws, and cations are positive. Okay, so just always remember that. And so cations are positive because they have less electrons. And so the word cation and anion both have one part of it common, and that's the part ion. So the word ion just means that it has a different number of electrons than the neutral atom. And so if it is positive, it's a cation. If it's negative, it's an anion. And so with that, I want to give us a term for what it means, for example, for these two on the outside. So if we look at these, how they have a different number of neutrons, okay, that word is isotope. So we're going to give ourselves a definition of isotope. So an isotope are atoms of the same element with different numbers of neutrons. And so because of that, it means they also have different masses, because the mass is your protons plus your neutrons. So if you have a different number of neutrons, you have a different overall mass, but they're still the same element because they have the same protons. And so we would say that this atom here is an ion of this one, and the one on the right is an isotope of the one in the middle, or they're both isotopes of nitrogen. And so hopefully this kind of explains protons, neutrons, electrons, and how they kind of change and fluctuate, at least with the electrons and the neutrons, to form either an ion or an isotope.